Hello everybody, Kelvin here, and the topology which I'm going to be working on today is of one which I've created myself. I'm going to be using the Viata vRouter along with other various Cisco devices, and I've got two end devices, virtual machines, Windows 7. I've kind of listed some of the things which I'm going to be configuring just here. The one at the bottom, VRRP, Virtual Router Redundancy Protocol. Now, where I'm going to implement that is, let me just draw a little line for you guys. I'm looking at implementing it across here. Now, the only reason I'm looking at implementing it across there is because the Viata vRouter only supports VRRP. Don't support HSRP, which is Cisco proprietary as far as I'm aware. So I'm going to be implementing it across the Cisco device to the vRouter device, just for configuration purposes, just to reinforce my knowledge of configuring these devices. However, if I was implementing VRRP, ideally I'd like to have probably the vRouter here, I'd have another router here, and I'd have two links connected like that. So one would be on active, one would be on standby. So how I'm going to be doing it here is I'm going to be probably active and standby here, or vice versa. So that's how it'll be done. But as I say, I've set up this topology myself, and it's just I've set it up so I can configure different things in preparation, ready for my vRouter certified vRouter engineer exam, which I have coming up next week, in fact. So that's the main purpose of this video. If there's anything that you'd like to see more in depth, more detail on, do drop a comment, and I'll try to do a video based on what you want. Especially if I get enough comments requesting something. So we're just going to start now. So I've powered up the devices just to save some time. I haven't powered up the Windows 7 clone yet. I have, sorry. However, the link light's still showing red for some reason. So we're just going to go along with it and see how far we can get, and troubleshoot any issues that we do come across. So I'm going to start off with setting these interfaces up for the switch. So let's just jump on here. So we've got fast Ethernet 01 and fast Ethernet 02. So we'll just console in. Interface range, fast Ethernet 01 to 2. And the switch is just going to be acting as a pass-through. So all we're going to do is a no shut or no shutdown, and we're going to leave it as that because we don't need to put anything else on the switch. So we'll just verify that with a show interface fast Ethernet 01. I've got a lot of stuff running on this computer, which is why it might take some time for certain things to load. So as you see there, we have the lines up and the protocols up, which is good. We'll just verify fast Ethernet 02 as well. Yep, that's the same as well, so we're fine with that, so we can move on. So the IP addressing scheme we're going to be using is 192.168.1.0 subnet, and we'll just verify the IP address that I've set for the Windows 7 PC. As I say, do bear with me, as sometimes it may run slow, as I have a lot of things running at the minute. yeah, so it's auto configured at the minute because we have DHCP enabled on this end device, and I'm going to be setting, as it says there, DHCP for area 1. So we need to set up a DHCP server on the vRouter, so we shall do that now. There we go. So if you've been watching my other videos, you'll probably have realised that the vRouter is a different language to the configuring Cisco devices. If you do want to know more about the vRouter, get in touch. I'll try to do some videos for you guys. So we're going to do configure, and what we're going to do is we're going to set the DHCP server, but before we do that, we'll set the IP address for the interface, which is Ethernet 0. So we'll do a run show interface Ethernet 0, and as we can see, it hasn't got an IP address. So I will start by set interface Ethernet 0 address, and it's going to be 192.168.1.1/24, and we'll commit that. There we go. So now we'll set the DHCP server. So set I think it's service, yep, DHCP-server, and we need to give it a shared network name. So we're going to call that we'll call that lab. Okay, then before we edit the subnets, we'll enter that, then we'll go into edit mode. So instead of set, we jump into edit. Now we need to set the, I'm just in a question mark there, so we need to set the subnet for the shared network. So it's going to be 192.168.1.0. okay. Let me just double check it's not asking for the, yeah, it wants the mask as well. So 192.168.1.0/24. Then we do a set we're going to do a shared network. No, we're not going to do shared network parameters. So what we're going to do now is we'll edit the same. So we'll edit that with subnet, edit lab. No. Let me just exit out of there, in fact, because I'm still in there. So edit service DHCP server, and the shared network name, which is lab, as it's come up there. Then we'll subnet, subnet 192.168. There we go. So we'll it displays a list of options there, but we'll jump into that line there. Then we'll start setting additional parameters now. So we'll do the set question mark, and we're going to set the starting IP address. So I'll set start, and it's going to be 192.168.1.1, and we're going to stop address. In fact, no, what we'll do is we'll start the to show that DHCP is working as well. We'll set it as 1.20 to start, and we'll do stopping at 192.168.1.21, as there's not going to be any other devices on there. Okay, and we need to enter a NAT, and we'll do set default router. Okay, and the default router is 192.168.1.1. okay, and we'll do set We ain't got no DNS server. Let me just have a look, make sure I'm not missing anything out. We've got the default router, DNS server we don't need. Lease times we won't change. Static routes we don't need to add. We've added the starts. Yes, so let's go ahead and we shall commit that. There we go, so that's done now. So we'll just exit out of that now and we'll just turn our attention back to the Windows 7 computer for now. And we shall, right, okay. What we'll do is we'll disable the interface and then re-enable it. There we go. Now what we'll do is we'll re-enable it and see what happens here now. I'll just turn that off. There we go, so DHCP is active. We've been given the IP address which we set for the start, which is 192.168.1.20. Subnet masks is all correct, and the default gateway is 192.168.1.1, which is the vRouter. So that's all good and working. So we'll verify that with a quick ping. So we'll do cmd and we'll ping the gateway 192.168.1.1, and there we go, getting replies. So we know that that's working now, which is great. So we'll leave that for now and we shall exit out of that and we'll do show DHCP server. Oopsie, incomplete command. And we'll show the leases. And there we go, we can see that the 192.168.1.20 is leased. It's got the MAC address of the device, the lease time, the pool which it's in, which is lab, which is what we created, and the client name, as you can see on the end just there, it's Keltest, which is what I've called that Windows 7 PC. So we know that that works. So just go back on there and we'll just have a look at the statistics. There we go, so the pool size is 2. One's leased, so one's available, and the pool is the lab. So we know that that's all working now. So we'll move on. So now we're up to the vRouter. What we're going to do now is we are going to configure OSPF, multi-area OSPF. As we can see that the left hand side of the topology is in area 1. We've got the backbone, which is what I've called the backbone, so that's area 0, and we have area 2 on the right hand side. So we're going to configure multi-area OSPF first on the via vRouter, and we're going to configure the multi-area OSPF on the 2 Cisco devices, and hopefully they should all form adjacencies. And what we'll do then is we'll move on to configuring NAT address translation. So let's go. So what we need to do is we need to go back into configure. Okay, and we need to set protocols OSPF, and we need to do area 1 and area 0, as we've got links in area 1 as well as the backbone area as well. Okay, so we'll do area 1 and we'll go into edit that area. So we'll just up arrow, then change the set to the edit. There we go, and we'll do is set. We won't do the area type, we'll just do the network. So the network is 192.168.1.0 /24. There we go. Then we'll exit out of that. We'll up arrow to set area 0 now. Then we're going to edit that. Edit area 0. Okay. Then we need to set the network or networks of 172.16.10.0 and 12.0. So we'll do set network, and we're going to do 172.16.10.0 /29, and we're going to do the same again, but it's going to be 12.0. Okay, that's that done. Now we'll just exit out of that. Set protocols OSPF, and we need to set the passive interface, which is going to be Ethernet 0, I believe. Let's just double check that. Yeah, there we go, Ethernet 0, because we don't want that the LAN interface receiving the OSPF updates. So that is done, I believe. Just give me a second. Right, yeah, let's commit that. There we go. So that's done. However, now we need to configure the IP addresses for each interface. So we'll start off with this interface, which is Ethernet 1. So we need to do set interface Ethernet 1 address is 172.16.10. We'll do 10.1 /29. Okay. And we'll do the same again. Set interface is Ethernet 2, is it? Let's check. Yep, Ethernet 2. Address and 172.16.12.1 /29. And we shall commit that. There we go. So that's all done now then for the vRouter so far, configuring the multi-area OSPF. What we'll do now is we'll jump onto the Cisco devices, configure the interface, IP addresses, and configure multi-area OSPF. So we'll start with router 1. So conft, we'll verify that interface. Fast Ethernet 00. Let me just double check that again. Yeah, fast Ethernet 00 and 01. 00 and 01. So we're going to start at 00. Interface fast Ethernet 00. And we'll apply the no shutdown command. IP address is 172.16.10.2. When it catches up, 255.255. Oopsie. Entered before I'd finished. Let's just go back up. Up arrow 255.255.255.248. Okay. So that's that done. And we'll jump into interface fast Ethernet 01. IP address is going to be 172.16.11.2. We'll do that one. 255.255.255.248, and we'll apply the no shutdown command to that. And we'll end it first, and we'll do a quick ping to 172.16.10.1, and we can see if it's there. We go. So yeah, ping successful. So we know them interfaces are now connected. We won't ping the other interface yet, as we haven't connected to router 2 yet. So now we'll jump back into global config and we'll configure multi-area OSPF. So we'll do router OSPF 1, and we'll add the networks. So network, no, in fact we'll do the router ID first. We'll do the backbone areas ID is we'll do 0. I've never tried that before, so it must be 1. So we'll do 1. Okay, we'll stick with 1, and we'll call area 1's router ID. We'll go back and change that because I forgot to do that. We'll do that as area. Well, we'll do the router ID as 3.3.3.3, and we'll stick area 2 as the 2.2.2.2. Okay, so we'll do network 172.16.10.0, and if you noticed on the VRRP router with the subnet masks, you didn't need to enter them, you just enter the actual mask. So like /29, for example, you just enter that and it takes care of the rest, which I think is pretty cool, really. So you wouldn't need to do this. So 0.0.0.3. That's one network, so hopefully that adjacency will form when I do it in area 0. I'll just give it, there we go, we've had an adjacency form with 192.168.1.1. Okay, I need to change that router ID, but that's good. So we'll also add the network connecting to router 2, even though we haven't configured that yet. So it'll be network 172.16 fat fingers 11.0 0.0.0.3, and that is going in area 0. Okay, cool. And the adjacency won't form yet because we haven't configured router 2. Okay, so just end that for now. We'll do show IP OSPF. We'll do neighbors. See, question marked it. So yeah, we've got one neighbor at the minute. Okay, designated router. We're going to change that neighbor ID shortly. In fact, we'll go back and change that now. Before we we'll do no pinging yet. There we go. So we'll do edit protocols OSPF, and we'll do the area just give me a second, let me try some of that. Yeah, there we go. Sorry, perimeters. router ID. I knew it wasn't in the area, you changed it. So what did we say? We're going to give this 3.3.3.3. Now we'll need to clear the OSPF. Saying that it's saying that we can't do it at this level. So what we're going to have to do is we need to set it. We're not editing it, we're setting it. There we go, so that's better. We'll commit, and once we commit we should get a message to clear the process table. There we go. So we'll do the we'll exit out of there. Okay, do it. In fact, reset IP. Yeah, no, it's not going to let me do it there. So we'll exit out of that. Reset IP OSPF process. There we go. So that process should be resetting. If we take a look at router 1 now, we'll do the neighbor again. And as we see there, it's picking up 3.3.3.3. So we'll just clear IP OSPF process. Yes. And it should pick up the right one now. So it should load back up in a minute. We'll just wait for that. There we go. So it's loaded. So if we do the show the neighbors now, show IP OSPF neighbors, there we go. So we've got the neighbor ID now, and we've got it as the designated route. Now that may change when we add the other neighbors. We shall see. So now we need to go on to. Did I set the OSPF for 12.0? I think I did, didn't I? We shall see anyway. So what we'll do is we'll jump onto router 2 and we'll configure the interfaces first. So we'll just verify these that we've got. We have fast Ethernet 00 and 10. So we'll start off with interface fast Ethernet 00, and we'll do the IP address of what did we give that one? We give that one 2, didn't we? Yeah, so 172.16.11.1, 255.255.255.248. Apply the no shutdown command. Okay. And we'll jump onto interface fast Ethernet 10, and we'll apply the IP address of 172.16.12. What did we give it on the other one? We'll go with 255.255.255.248. No shutdown, and what we'll do is we'll just verify those by trying to ping the attached device. So we'll start with pinging the 11 network, 172.16.11.2. So that's all good. And we'll do a ping to the vRouter, 172.16.12.1. We'll go away. And yeah, that's successful. So we know that those are configured correctly. So now we need to set up multi-area OSPF conf-t, and we'll do router OSPF 1, and we need to do the router ID, which we said was going to be all 2s, and we need to add the network. So network 172.16.11.0. 0003 for the wildcard mask, and that's in area 0. And also, there we go, we've added the adjacency form there with the backbone router, so which is router 1. Network 172.16.12.0. Wildcard mask is the same, and that's area 0. Hopefully the adjacency forms with this. If it doesn't, then I haven't created it on the vRouter, so we'll go back and do that. If not, there we go. So yeah, the adjacency is being formed, which is good. So now we know that that's all working. So we'll just do an end, and we'll do show IP OSPF neighbor. There we go. I'm just going to clear the process, clear IP OSPF process on all the routers. I think I've got it up there. And the vRouter reset IP. See, the commands are slightly different for the vRouter. Configure. Right, let's just check the. In fact, we'll do a run show protocol. Well, let me do it in here. Show protocol. The IP OSPF neighbors will do on this. There we go. So we've got 2 neighbors, which is good. We'll just do the route. So as you can see there, the areas there are displayed as well. We'll just have a look at the database. Okay. .2, 10.1. Okay. Yep. So all the routers there are advertised. So what we'll do, I'm going to show IP OSPF neighbor. There we go. So okay, you see there full BDR, which is the backup designated router. Okay, that's router 2. Jump on to do the same for this. So IP OSPF neighbor. There we go. So the designated route neighbor 2.2.2. That's the designated route there. And we'll see if it's changed on the vRouter. No, both of them are designated routes there. Okay. So anyway, enough of the show commands. What we'll do is we'll try to, from the Windows 7 PC, give me a second, there we go, we'll try to ping, where are we? We'll try to ping that interface on router 2, which I believe is 172.16.11.1. Okay, so we'll try that now. So ping 172.16.11.1. Yep, so we're getting a reply there, so that's good. We know that OSPF's working great. So we've configured multi-area OSPF on the VRRP router as well as the Cisco routers. Configured DHCP. So what we're going to do now is, just before I jump ahead, in fact, I'll configure the interfaces just to as a no shutdown, just so that the interfaces are up for area 2. So we'll do that on a switch. Just verify these interfaces. So we've got Ethernet 0, 0 and 0, 1. So conf-t interface range fast Ethernet 0, 0 to 0, 1. And we'll just do the no shutdown and show interface 0, 0. Yep, that's fine. Up, which is good. We'll do the same again for that one. Yep, up, which is good. That's cool. Okay. Let me just configure the IP address now for this interface here. So it's fast Ethernet 0, 1 on router 2. Conf-t interface fast Ethernet 0, 1. IP address is going to be 192.168.2.1, 255.255.255.0. Apply the no shutdown command. And what we need to do is set this as a passive interface. So router OSPF 1 passive interface fast Ethernet 0, 1. Okay, that's cool. Exit out of that. So if I know the link light here is shown as red, but I do have that machine running, so let me just try set the IP address and we'll see what happens. Right, let's have a look. It's static as well, we haven't done DHCP like the other side. 192.168.2.2. Yep, 2.1. Okay. What we'll do, we'll just disable that and re-enable that, because I think that's an IP address a configuration from a previous lab I did. So we'll enable that, and yeah, there we go, we have connectivity. That's good. So let me just verify that by sending a quick ping to the gateway, 192.168.2.1. Yeah, that's good. So we know that that's working, even though the link light on GNS3 is shown as red. So we should be able to ping the left hand side PC. So let's have a look. 192.168.1.20, isn't it? Yeah, 20 is the start we'll give it. Oh no, is it 20? Let's just verify that just to be on the safe side. Let's have a look. Yeah, 192.168.1.20. Okay. So let's just try and send a ping. And then 2.168.2.1. That destination's unreachable. So it can still ping. Right, okay. That's good. So it's not able to ping. Let me see if I can ping 1.1. No, it don't look like it. For some reason. So what I'm going to do is I'm just going to run a few ping tests. So we'll start with router 2. We'll do a ping 192.168.1.1. That's cool. Let's see if I can ping the device. Yeah, so I can ping the device from router 2. So let me see if I can ping 192.168.2.2. That's okay. And I can ping 172.16.11.1 and 2. And okay. So tell you what I'll do. Just give me a second and have a look at this. So let me just see if I can. We'll set up the static routes on router 1 for each LAN. So we'll do a conft IP route. We'll do 192.168.1.0, and we'll do that next stop interface. Let's have a look. So it'll be 10.2, I think we did. Wrong router. 10.1. Yeah, 10.1. Okay. We'll add another route for sorry, I'll just move that up so that you can see it. We'll add another route for 2.0, and the next stop IP is 11.1. Let's see how that works out. So we'll do a ping to. No, that's not that's unreachable. Let's just have a look at this again. Just double check all these interfaces. So, well, they must be active. Right. I think I know what we haven't done. We haven't added the network for area 2, I believe. So let's just do a show IP OSPF 1. Yeah, we've only had the added the backbone. So let's do a IP OSPF 1. I mean, not IP, router OSPF 1, and we'll add network 192.168.2.0. Wildcard mask is 000.255, and that's in area 2. Let's confirm that. Yep, area 2. Enter. So we'll do end, and let's hope that this works now. So we'll do a ping 192.168.2.1. There we go. Now it's working. We didn't add the network. Yeah, so we didn't add the network. So let's just 192.168.2.2. There we go. So it's reaching end to end now. The static routes I have had added, I could change the administrative distance on them and have them as floating static routes as like a backup to the OSPF, but we'll leave that for now and configure the other stuff we have on our list. So what we'll do now is we've done the multi-area OSPF, barring our little blonde moment we had. DHCP for area 1 is done. Static IP addressing, we've done that. Static routes, I did create the static routes when we were troubleshooting the OSPF. As I said, they are good for even with dynamic routing protocols such as OSPF. When you want to create like floating static routes, just in case anything happens with the OSPF. However, for now, what we'll do is we'll leave the floating static routes and we'll concentrate on we'll move on to configuring NAT. So what we're going to do is we're going to configure static NAT on, I'm only going to do this on the VRRP for the purpose of my upcoming certification exam, and we will have a look at the translations on Wireshark if I can get that running with everything else. So what we'll do is we'll go ahead and we'll jump onto the VRRP. Here we are. Apologies if any of the commands syntax has been below the recording line. It's just the way I started the video, unfortunately. Configure. Okay, so we're gonna set NAT static no source, and the rule will be 1. So we'll go with that and we'll edit that. Sorry, fat fingers again. There we go. So now we'll do a set translation. So the address, we won't go with port address translation, we'll do the address. So there's a little option, I'll just get my pen up there, masquerade. Now what that is it'll map the address to the primary outbound interface. So as we've only got one address on the outbound interface, we'll just do that to simplify things. So masquerade, okay. We'll do set source address, which is we can either specify a single address or we can do the subnet. So we'll do the subnet 192.168.1.0/24. Okay, and we'll do set outbound interface, which is the outbound we'll go with fast Ethernet 00. I tell you what, let's try set 2 outbound interfaces. I haven't tried that, so we'll do 1 and 2. We'll try that. Okay. So we'll do. Let's get up here. So we'll do Ethernet 1 and set outbound Ethernet 2. Commit, and it's allowed it. So we'll exit out of that because obviously we've got 2 paths to area 2. So you know, we'll see what happens. Okay, so we'll do a run show NAT source statistics. In fact, we'll do translations first, because when I press enter there, you see that there's no underneath the pre-NAT, post-NAT, etc. And the reason is we haven't done no translation yet. So what we're going to do is we're just going to send a ping from Windows 7 PC across to the other side of the network, so 2.2, and we'll jump back on here and we'll do the translations again. And as you can see there, we've got the translation coming up now. So the pre-NAT address is the 192.168.1.20, which is the actual end device. The post-NAT is 12.1, so it's actually traveling through. Let's just minimize these. So we set 2 outbound interfaces, but it's traveling through this interface here. Okay. Let me just get it back up. Where have we gone? And the timeout, it should have timed out by now. So if we do it again, there we go. It's not there. It's timed out. So if we do, we'll look at statistics. So we've got one rule, and it's just showing like the packets and stuff that are being sent, which is the last ping that we did, and the outbound interface is showing Ethernet 2. Okay, what we'll try to do as well, we'll try shut down the interface which it's going through, and see if it goes through the 172.16.10.1. Might as well just have a play about and show you guys what's going on. So we can do rules. Oops. There we go. So we've got one rule, Ethernet 2 passing through. Source address is the subnet to 172.16.12.1. Okay. Okay. So I'll tell you what we'll do. We'll just disable the Ethernet 2 in it. So we'll do, I don't know if it's edit interface Ethernet 2. So we're going to disable interface. So don't know if that's all done there. Let me just exit out of that. Sorry. So it's already put it in anyway, even though we did. So if we exit out of that, and we take away run. Right, we've got no translations yet. Statistics, so it's showing it's still going out of Ethernet 2. Let's try send a packet and see what happens. So let's have a look at the translations. So it's coming up there now. Pre-NAT is the end device, post-NAT is the end device as well. Okay, so if we do these statistics, it's still showing that it's going out of Ethernet 2. Let's have a look at the rule. Yes, it must be Ethernet 2. But I did set 2 interfaces, so let's just go back in and have a look at that. Edit NAT source rule 1, and we'll have a look at the outbound interfaces. That will set it, and it'll tell us if it's already been set. If we set Ethernet 1, it's not come up, so we'll commit that, exit out of that. We'll take a look at the rules, and now it's showing it's going out of Ethernet 1, so it looks like it can only set one interface, I believe. Let's just go back into configuration, edit NAT source rule 1, and we'll look at the translation. We don't need to do the port. Translated IP address or range. NAT to a specific, NAT to specified IP range. NAT to a specified network address. Okay, so let's have a look, see if we put in, just minimize this, see if we put in the IP addresses for each one. So it'd be mapping to 172.10.1/29. Let's just change that to set. I always do that for some reason. Yep, set. There we go. And we'll set up 172.16.12.1. Alright, let's try commit that. No, it's not let us. Source address should be a subnet with the same network. Okay. So if we discard that, changes have been discarded. Now we need to delete interface Ethernet 2, disable. That basically reactivates the interface. That's done now. Exit out of that. Let's do a show NAT rules. So it's going out of 172.16.10.1. There is another way we could possibly try add both, and that's by creating a second rule. So let's just have a go with that. Configure, and we'll do set NAT source rule, and we'll do 2, and then we'll edit that rule. There we go. And now we need to set translation address. So it's going to be, let me just go back first. Yeah, because we've already set it on Ethernet 1, so we need to do the set translation address, and we'll do the masquerade, and we'll set outbound interface as Ethernet 2, then set the source address as 192.168.1.0/24. Commit that, exit out of that, exit out of that, and we'll have a look at the rules. So we've got 2 rules there now. We've got translating the same subnet out of 2 different interfaces. Okay. So we'll have a look at the show NAT source statistic. No, we'll do the translations. Sorry. So there's no translations yet. We'll just do a quick ping again. Okay. We'll have a look now at the translation. So the pre-NAT, so it's choosing to go now through 172.16.12.1. So it's choosing to go straight through and bypass obviously the router 1. Okay. So if we do show source statistics, there we go. We've got one rule, the packets which I've just sent, the ping, then it's gone, obviously use rule 2. So if we disable, we'll try again now, and we'll disable Ethernet 2, set interface Ethernet 2, disable, commit. Right, let's exit out of there. Translations again, we'll do a ping now and see if it goes through the other interface. Oops, get off that. Okay, go back on here. Yep, so it's worked. So that's how it goes. So the pre-NAT is the end device, the Windows computer. The post-NAT has now changed the interface to 172.16.10.1. Okay. And if we do the statistics, there we go. So you can see now what's happened. So what we'll do is we'll re-enable Ethernet 2, configure, and we'll delete interface Ethernet 2, disable, commit, and we shall see if it takes a shorter path now through straight to discarding router 1 and straight through to router 2 instead of going up here. It'll go straight through. So we'll just do another ping. Let me just get my translation there. We'll just do another ping, and we'll see the translation now. Oopsie, we need to exit out of that. Yep, so it's decided to change its route again. So it's choosing the quickest route. So showing that statistics, there we go. So yeah, it's choosing the faster route. So now that we've inspected that in quite a bit of detail, we will now load up Wireshark, and we'll do it on this interface, which is 10, to inspect the source and destination which it's displaying. So it shouldn't display any network from inside area 1 to the destination. It should display the outbound interface IP address, which is 172.16.12.1. So we'll just inspect the packets and have a look at that. With NAT, if you've not looked at it before, it's just like an extra layer of security, really, when you think about it, because the LAN networks are hidden and all the translations done on that interface there. You can set with this VRRP vRouter, you can set source NAT, destination NAT, and you can set bidirectional NAT. I won't be doing any of that today, but I just thought I'd put it out there. So what we'll do now is we'll do capture. Might take a little while to load, and we're capturing 10. The packets are going to be coming through. And we'll just wait until Wireshark loads up, then we'll inspect some of the packets. And with OSPF working as well, we should be getting hello packets quite often as well, popping up. So we'll just let that load up. What I'll do is I'll pause the video until this is loaded, and we'll pick up where we left off. So picking up where we left off, Wireshark is now running, and as I mentioned before, you can see hello packets and replies, which is for the multicast OSPF, to keep the adjacencies. We'll just get off that for now. You've got a link state update, link state acknowledgement coming through. We won't cover these in detail as much today. We'll just have a look at the network address translation. So what we'll do is we'll send a ping through to the other side of the network, and we'll see the translation. There we go, it's coming in now. There we go. So there it is. So let's have a look here. The source IP address is 172.16.12.1. So even though we sent the request, the ping request from the end user device, which is 192.168.1.20, it's been translated. So the destination will only see this address 172.16.12.1 because it's added that on with the NAT translation. The destination address is still the same destination address, and you've got the request and the reply. So when the reply is coming back, so the reply from 192.168.2.2, which is the other end device, it sends the reply to 172.16.12.1. So it's, even though the reply is going to the end device, it's actually going these all in that network, that subnet there, 172.16.12.1. That's the one that's known there. Okay. So then from the source, which is known as the source, so instead of the 192.168.1.20 known as the source, it's the 12.1 known as the source, sends it then the packet to its original destination, which is 192.168 2.2. Sorry, that's sending the request again. Sending it again, sorry, to the destination. Okay, so that's pretty much how the NAT address translation works when you're looking at it, when you've successfully configured it. And that, as I said before, that reply then goes from the 172.16.12.1 to the original device that initiated the ping request. Okay, so that's looking at the NAT. So we know that we've got NAT working now. We've done a few show commands to see that NAT's working. So we'll I'll tell you what, we'll leave Wireshark running for now anyway. We'll just see how my PC performs with it. So we've done the multi-area OSPF, we've configured NAT, DHCP for area 1, static addressing for area 2. We've configured them static groups, which we did when troubleshooting. Now we're going to configure the virtual router redundancy protocol. Now, at first I had HSRP on, which we're going to configure, and I'm aware off the top of my head that that's a Cisco proprietary protocol, and the VRRP router doesn't support that. However, it does support VRRP. I haven't worked too much with VRRP yet. However, I have configured it on the V router. So what we're going to do is we're going to configure VRRP on the V router, and we'll configure it on router 2, and we'll create an active and a standby. It works the same way as HSRP if you've worked with HSRP before. So yeah, we're going to go ahead and we'll start that now. So we'll jump onto the V router first. Configure. And can't remember the actual command for it. Let me just so I think we need to do it on interface. So Ethernet 2, yeah, VRRP. VRP group number, we'll give it a one group number. Then we'll go into edit mode, and we'll set virtual address. We'll give it the 172.16.12.1. Okay. Set. We won't set the authentication on it, or description. We'll set the priority so that this one takes priority over the other one configure. So we'll set the priority as we'll give this priority 2. Okay, that's that done. So we'll just get on to router 2, and it's interface 10. The adjacencies there are when we kept shutting down the interface. So they just formed adjacencies again. So interface, let's bring it up here. 101. We'll do VRRP 1. Oopsie. And we'll do priority. We'll give it 1. VRRP 1. And we'll give it an IP of 172.16.12.2. Was it? Yeah, we'll give it that. And it's changed it now. It's formed it's formed the link group 1 state master. So let's have a look at this. This should be standby. So we'll look at VRRP1 preempt. So we'll put that on and show VRRP brief. So the master address is its own, so it is the master. So let me just have a look at the vrouter again. Committed the commands, so give me a second. Set preempt. And we need to do tell you what we need to do. Delete virtual address 172, and we'll set, oops, I've got capitals on now. Set virtual address of 172.16.12.1/29. Set the I don't think we need the LL source address because that's optional, so we'll leave that. Let me just look at the router 2 again. So just shut that down a minute. No shut. Let's change the VRRP1 need to change the priority 1. Let's give it priority 2. Priority change will have no effect whilst interface is VRRP address owner. Okay. Let me just try something. No. P1 IP. There we go. So it's changed to the backup to the state, backup to master. It's taken master. Right, give me a second. Let me do the no VRRP priority. VR1 priority 2. Give this priority 1. There we go. So it's changed now from the master, as you can see there, to the backup because I've changed the priority to 1. The higher priority takes over. So we'll just do a few show commands on each device. So it's shown as the owner. So the state's in backup. So just give me a second because let's just do a config T interface fast Ethernet 10. No VRRP1 IP 172.16 12.1 VRRP1 IP 172.16 12.2. If I change it to 2, I think it takes. It's changed it to master because I've changed the IP address from the group IP address. So yeah, that's right. So if we do a 12.2 and we change it to 12.1, it should take back up now. There we go, it's taken back up. So what we'll do, just to see if the priority changes, we'll change the no VRRP1 priority 1, we add it, and we'll change the priority to 3 because the priority on the V router is 2. So we'll change the priority. So it's taken master there anyway. So if we change it back, it's taken master now that we've taken that out. So if we just do the priority 1 again, it should take back up. There we go. So it's changed to backup. So we know that that works, which is good. VRRP all. Okay. So virtual IP address is displayed. The state is in backup state as the vRouters took the active state. Preempt is enabled. Priority is 1. Master router is 172.16.12.1. Their priority is 2. So see the higher priority is taken the master. And then it's got the master advertisement intervals. So if let's just do we'll shut down Ethernet 2 again, and we should see that router 2 takes priority. So we'll do set interface Ethernet 2. Oh, we need to exit out of that mode. Give me a second. Set interface Ethernet 2 disable. Commit that. Now router 2 should take priority on the left. Hopefully. There we go. So now it's taken the master, as we see there, because that interface has gone down on the VRRP router. So as I said before, let me just do my little squiggly drawings. Ideally VRRP works best where you've got your one router here, which is a V router. You have another router here, and these two routers then are connected to another one like that. So if one fails, yeah, that's right, yeah. So if one fails, so that's going wherever it's going. So if one fails and the other takes over, that's the point in the active standby sort of thing. So yeah, that's pretty much it with this topology today. We've gone through various show commands on the vRouter as well as the Cisco devices, and we've managed to get everything up and running as we wanted to, and troubleshooted problems as we come across it. So any questions, feel free to drop me a message, get at me, let me know what you thought of the video, and yeah, look forward to producing my next video real soon. If there's all you guys want to see, as I said at the start of the video, in terms of the vRouter or some sort of configuration with Cisco devices, etc., again, just get at me, and if there's enough interest in it, I will provide the video for you guys. But that's it for now. Thanks for watching.